Hello and welcome to the Capstone presentation for the Smart Mold project, sponsored by Carlisle Construction Materials. Carlisle is a manufacturer of many materials, one of which is polyiso insulation panels used as a thermal barrier in commercial buildings. This insulation is produced by a reaction in which the products rapidly heat up, expand, and harden. For these panels, Carlisle desires a constrained rise mold with the ability to measure temperature, rise height and velocity, gel point, and curing time of the foam throughout the reaction. Their existing rectangular mold and the current state of the art for a free rise application, the Foamat 285, are pictured in the bottom right. In the development of our project, our team designed and fabricated two mold prototypes based on the needs of our sponsor. The alpha prototype was made of OSB and fastened using wood screws and L brackets. In this iteration, we used an ultrasonic sensor for rise height, a pressure sensor to identify gel point, a thermocouple for temperature, and a capacitive sensor to measure cure time, since our research showed that dielectric polarization can indicate curation. With the exception of faulty pressure sensor wiring, the alpha prototype worked as we'd hoped. The beta prototype was more oriented towards practicality and using multiple capacitive and pressure sensors. Our team traveled to Carlisle to test the prototype with our sponsors, and this is where we see that the latching mechanism and sliding thermocouple make it very easy for the user. Although sensitivity and noise need to be managed in our capacitance sensors, the expected trends were observed in the data. The deliverables we made for our project include a SolidWorks model based on our retrofit of the existing mold, a wiring schematic for the Arduino, and a MATLAB and Arduino scripts which were used in the beta prototype. For the beta prototype, we created a MATLAB script that interfaces with the Arduino and presents a graphical user interface to the user. This interface allows the user to specify a board, port, and runtime for the test. Once the program is run, the script outputs plots and a CSV file with the date and time in the title. Although the same hardware is included in the beta prototype and the final SolidWorks design, we recommend placing the conductor for the custom capacitive sensor inside of a thin insulating pocket since the existing mold is aluminum. Like the beta prototype, wiring is run through the bottom plate to the back of the mold where everything connects through a breadboard to the Arduino. The ultrasonic sensor is the only sensor in the lid. Seen here, our SolidWorks model includes mock sensors and the L-shaped tube and bracket for the sliding thermocouple. Our model also takes into account water channels used for heating the mold so as to not impede the expansion of the foam. We hope that ultimately this model and other deliverables will provide a reference for further development moving forward. We hope you have enjoyed our presentation of the Smart Mold Capstone project. Thank you.